Hello everyone. In this project we are going to build an image editor application using Tkinter and OpenCV. So Tkinter is the front end, is the graphical user interface which the user can interact with, and OpenCV is the back end where the image processing actually takes place. All these filters and so on. So before we dive into the project or any other details, let me just show you a quick demonstration of what you are trying to build here. So let me run the application and we can see a window here. So this is a single window application. I can start by uploading an image. I am provided with a lot of options here. So I can crop the image. So I just need to select the area of interest that I am interested in, and it will be updated in this canvas. I can apply it to keep these changes, or I can cancel to bring back the original image. I can add text here. And I can place it in the image in the desired place. I can draw over the image. By default the color is red. I can pick any other color as well. So here is the apply filter section. There we have a lot of few filters application, few filter buttons: negativity, black and white, stylization, sepia, erosion, dilation, etc. So in this menu I did not provide any flexibility for the user to actually change the amount of negativity or black and white that he wants. It's just this button, and it will process the image on the pre-computed values that I gave for the application. Whereas in these two sections I did provide the user with a flexibility called slider here. So I can increase the amount of blur that I actually want, and it will be instantaneously updated in this canvas. Likewise for brightness as well. By default the brightness scale is 1, so if I go less than 1, it will just darken the image. And also for saturation is kind of the same working. I have other options like rotating in the image, flipping the image, and so on. So in the end I can just save the image and it will be saved as a new file. So this is what the entire project is about. Let me just show you a bit more details. So the OpenCV Python library is the backend. It has a predetermined set of functions that I can use to apply these filters that I showed you. And the Tkinter is for an abstraction layer for the user, between the user and the backend. So one can start actually uploading the image and select the filters and do whatever with the image. And as you can see, the results were quite instantaneous and it was fast, and the program is really quite easy to implement with Python. So I'm going to be providing you an exact roadmap of how we are going to finish this project so that everyone knows what we are actually doing. So first I'll start by covering the basics of Tkinter and OpenCV. So in this I provide what exact widgets we are going to actually use in the project and provide a strong grasp of those widgets only. And next we'll be moving on to developing the front end. So this time it'll be just a front end window. So I'll be having widgets and everything that you've seen in the application, but without any actual functionalities. The buttons won't be doing anything in this section. And next we'll be actually implementing the functionalities. We'll start by using the basic functionalities. So applying filters and some kind of other transformations are kind of basic. And then we'll be moving on to advanced functionalities, which are just cropping the images, drawing over the images, and so on. So we'll be needing these to be installed Python, and Tkinter most likely will be in Python when you install it. If not, you can install it. So NumPy, OpenCV, and Pill, we need to install them with pips, which is Python package manager. So in order to install these, I'll just say pip install NumPy, OpenCV-Python, and Pillow. So these are 3 libraries. I'm just separating it by space, and it'll be installing them when I click enter. So I do have them already, and it will just say the requirement is already satisfied or something. Yeah. So up next we'll be covering the basics of Tkinter and OpenCV just enough to implement our project successfully. Let's start with the basics of Tkinter in this video. So as you would have noticed, our application have a single window here, and inside the window there were several frames and so on. And inside the frames there were widgets such as labels, buttons, and some others like canvas probably. We will learn how to implement them and place them in the frames and place the widgets in the frames and so on. So let me just start by importing few things from Tkinter. So from Tkinter import ttk, tk. I'll be showing you what these are in a bit. So let me first instantiate a window here. I'll call it root window. So I'm going to instantiate from this class. So root is an object from this class tk. So it is a window here, and in order to run this window I'm just going to use like root.main loop. Let me run it real quick and then explain what's going on here. So my project is in E Python project and image editor, and the project name is python demo.py. Okay, so when I run this, a window has opened here, but it is completely empty for now because I did not have anything. But this is the root window that's exactly open here, and it's existing in this window as long as I can minimize it and do whatever because of this main loop event. So this main loop is just a way to wait for the user for some events, such as when I have a button here, it will just wait for me to click for a button if I want, and other types of like a key press. So it will just exist as long as I open the application. So when I close this application, the program ends. That's actually how it. So let me just show you. The program is running till now. I don't see any prompt here, but when I close it, the main loop ends and I can see the prompt. So that is the window, root window that we just saw. So in order to populate the root window, I can have few things like labels, buttons, and so on. So let me just show you a quick example of creating a simple label. So we are just going to use the label from ttk. So ttk.label. So the first letter is L, which is capitalized, and for the first argument I need to provide the window in which the label is going to be shown. So I have a single window which is root, so I'm just going to use it here, root, and next I just want to type the text that I want in this window. So this is a test label, and yeah, so this is an object till now. So this will return an object, but it is not placed in the window yet. In order to place it in the window, so let me just show you, and yeah, we have label but we don't see any output here. It's because I did create an object but I didn't say how to or where to paste it. For now I'll just use a pack method, which is by default stacks it on the layer. So if I run it now, I just need to close this first, and if I run it now, you can see a label is here. So I can maximize this. So it's by default like stacking it in the middle here. So I can have another label, use Ctrl C on this and paste it here, and it will be just pasted. So this is my second label, and I'm packing this as well. So you can see these two labels are stacked up vertically. So that's what the pack actually does by default. I did not say anything about like going to the sideways or being in the middle and so on. So there are many other types of systems like grid system, which is most commonly used, at least in this project, and the place system. So by place we provide exact coordinates like x and y coordinates, where to place this widget and so on. But for this project we'll be mostly focused on pack and the grid methods. So we've seen how we have created two labels here. So let me just show you another way though. I'll just delete this pack, and right now this is an object, so I can just store it in a variable here. My label object is equal to this. So I did not use a pack here, and the label is not placed in video. Now what I can do is I can call this variable and use the pack method on this one. So it should work the same. Yeah. So there are two labels. But many beginners might do this mistake. I personally did myself. I'm not sure if many others will do it, but be careful in this area. This won't work because we are doing a pack. It will obviously show it in this. We are doing a pack here. It will obviously place it in the window because this is a label that is packed. But if I print my label object, it is not an object anymore. You can see the written value when I run this program. Oh, oops, I accidentally closed the terminal. Okay, so when I print it here, it returns none. It's because whenever I use the pack method on this object does not be an object to be returned by to this variable. So whenever I use the pack, this returns none. So I cannot use my label dot pack here. This will throw an error because the none object has no attribute pack and so on, because I used the pack here and this did not return anything. But in this way this is legal. So whenever I want to use any other configuration for the label later on in point of my program, I will probably using a variable and then use it a pack method. So for example, if I have a button and if I want it to be disabled when it's clicked, I'll just trigger an event and probably have the button state as state equal to disabled and so on. So that button will be disabled. It was possible because I stored that object in this variable to be used later point in time. So that's it about the label here. And we can create a button for now. So button text, so let me create a button object, and it's exactly in the same model as well, ttk.button, and I'll provide the root text is equal to, because there's going to be text in the button, so I'm just going to say click me, and this is going to take a function as an argument in the command. So command is equal to let me show you, triggered function. So this is a user-defined function. I did not create it yet, but I am going to. So let me just pack it by default, and I am going to define the trigger function. Okay, so I'm just going to print I was clicked. Okay, so let me just run the program now and show you what happens. Okay, oh, so here we have two labels and a button, and let me just open the console here. So whenever I click the button, here we can see I was clicked pops up here. It's because I added a binding function here. So this button has a command that will be executed whenever the button is clicked. So it will just do whatever this function says to it. Now let's add an image as a label using the label widget. So we cannot directly add an image. We need to use something called photo image. So let me import photo image. First we need to create a file using the photo image. So we need to give the file inside the photo image. I have a Python GIF file here, so Python logo.gif, and now I'm going to use this inside the label instead of directly using the image here. So now ttk.label root comma now image equal to logo. So we don't have any text here, so I'm just going to have image equals logo, and I'm going to pack it. So if I now run the program, you can see the image here. So it is tagged up below the button here. So the image is kind of big, so if I want to change it, change the size of the image, I'm going to have to sample it. So that's done by using the photo images and using sub sample. Probably I'll use 5,5 here, and now if I run the program, yeah, it is good to be a logo here. Okay, so next let's see something about frames. So frames are going to contain the widgets inside of a window. So instead of directly having the widgets inside the window, root window like we did, we are going to create a frame, and those frames are going to manage the widgets inside them. So it won't disturb the other frames, and it provides a good way to structure the front end for us. So let me just clear all of these, and let me just have this label here. So in order to create a frame, it is exactly like that. So I'm going to name this frame header and ttk.frame, the usual. We are going to place the frame inside the root window. So now I'm going to pack the header, frame header. So now instead of this root, I'm going to display the label inside the frame header. So frame underscore header. So if I run this now, there won't be much difference because there's only one frame and it is the entire window itself. So we will be able to distinguish as we go on further in the project, but for now this is how we create frame and use the widgets inside the frame. Okay, so let me delete the frame for now. Yeah, so now in order to work on the image, there's canvas in Tkinter. So I'm going to input canvas here. So let me create an object by providing canvas, and it will take the first argument as in which window we need to have it, and you can have a background like background equal to gray, and we should provide the width of the canvas, for example 300 here, and height of the canvas as well. So it will produce a rectangular canvas inside which we are going to place the image. So I can just pack it for now. So let me create a photo image of the logo. File equals python logo.gif, and I don't want to subsample it. So now inside the frame, so I'm going to use canvas dot create image. So I'm going to be placing an image here, right? So first we need to provide a width here. So I'm going to be providing 100 comma and 200, and the image that we are going to use it here. So I think we need to use the image attribute. So if I run this program now, you can see, since I did not provide a perfect width for the canvas, so the canvas height was 400 and width is 300, but in this image, create image, I just provided 100, 200. It clearly did not match the canvas. So for giving it, we have to use half of the width and half of the height of the original image that we are actually trying to get. So the canvas height is 300 and 400. We want to contain this image within this canvas. So usual trick we are going to do is we are going to divide this by 2. So right now I can just compute it like 150 and 200, but in the future we'll be computing the image size and then dividing them by 2. So if I save and run them now, you can see the image is perfectly contained within the canvas. So that's it about canvas here. So next we are going to see about file dialog. So file dialog is used for opening the files from the window that asks us to open the files or saving the files and so on. So for uploading an image, for example, I'll click on upload image and it will help me to browse the computer's files. So this is exactly given by file dialog. So I'll just clear all of this. So the file dialog returns a file name of what file is being selected. So in order to open a file dialog, I'm just going to create file dialog dot ask open file name. Okay, so this will give the file name of what file I opened. So if I print file name, it opens the file dialog right away. So I should have a button, and when that button is clicked, I should open this file dialog. So let me just run it again, and if I just click some file here, and it will print the name of the file along with the path. So that's exactly how it works. So I should have a button here so that the event is triggered only when I ask it to, not when I just open the file. And likewise we have ask save image, like ask save as file name, and this is when we want to save the file to the directory, and this will be using in the project, for example, while we save the image after we have processed something. So this basics is just enough for us to get started with Tkinter. And right next we'll see about the basics of OpenCV. Now we're going to cover the basics of CV2, OpenCV. So we're going to be removing all of these and just import CV2. So first we need to import an image using cv2.imread. So this function is used to read the image, and in order to show the processed image, we'll use cv2.imshow. This function takes the file name alone. So for example, city.jf is my image, and this function expects two arguments. One is the name of the image, the name of the window that it's going to be displayed on. For example, this is processed image, and the second argument is the image argument returned by the CV2, either the read function or any other processed functions. So for example, I'm just going to show the same image, and if I save and run it, it actually worked, but we need to tell CV2 to wait for us to actually show the image. For example, the Tkinter main loop would wait until the user hits the close button. So all we need to do is cv2 dot wait key of 0 and cv2 dot destroy all windows. So if I run now, we should be able to see the image. Yeah, so this is the city.jfif that I've given it. So as you can see, the name of the file is this processed image, the window. So this is a required argument, you cannot skip it. So let's show you some basic common image editing functions. For example, I am going to use cv2.cvt color, and first argument is the image that we are going to apply, and the second is the actual value. So for example, effect color. So let me just convert into a black and white image, like a gray image. So what I'm doing is reading the image and storing it in the image variable, and the image is passed here, and this is the effect that I want to give. So cvt convert color contains color bgr to gray, and this will return the same, the processed image. And now I'm going to show the processed image. So if I do it, oh, it's not defined, I think it's cv2 dot, yeah. So now we can see the processed image, it's converted to black and white. And yeah, there are many types of images that we can apply. For example, I think it's bitwise not. So this is also kind of it is a binary image. Yeah, so this is a negative image, and yeah, it is inverted. So bitwise and not. So bitwise not is a single bit processing. So whenever there's a higher black color, it will just invert the image. So like this, in this way we are going to have various types of filters that we are going to have in our OpenCV project. So this should do it, and the many other syntax does not differ much. I'll just let you know whenever there's change in what you have learned, and I'll just add on while actually doing the project. Now we are going to start working on the front end. So this is the layout of the window, and there are 5 frames as you can see: header frame, the menu frame, canvas, and the submenu frame, and the footer frame. So header frame contains logo as a label, header and description, texts as a label, and menu contains the buttons, and each button will be assigned to a callback function here. And also, whenever one button is selected, the submenu for that button is appeared in this submenu. So for example, if I click on filters button here, and we can see the filter submenu will appear here. So this is exactly what we're going to do. So let me just start working on the code. So demo.py is our main now current working file, while main.file is my existing file where we can just copy code to avoid any waste of time. So most of them will be just repetitive code. I'll go explain on the way whenever I copy them. So we need to import ttk, tk, and also photo image for the logo. And let me import cv2 as well. Yeah, I won't be needing cv2 in this video. Okay, so let me instantiate a root from tk class, and I'm going to run this main loop. Now instead of using the widgets directly in this main function, I'm just going to create a class here. So class, let me call front end, and I'm going to use the initialization function. So constructor, which is self, and this is going to contain the root that I'm going to pass. So this class is going to use this root window. So for that I just need to call the front end class and pass the root. So the instantiated root window is passed to the front end and it is saved in the master here. So now the root is called master inside this class. So I can start by assigning it as a self variable. So self.master equal to master. So this just means this master variable is now currently within this function only, but whenever I use self.master or anything, you can name it, for example mast, but it's better to have the same variable for this as well. So this variable is going to available for the entire class as well. So if I create a second function here, so for example test, and it will take self as well, and I can access self.master here. So but I cannot use this master here because it's not defined. I can use this because I pass the self, and it will be the lifetime is quite around this entire class itself. So this is how I'm going to set up the self.master. I'm going to create a label, and self.master is the window that is going to contain the label, and .pack is what I'm going to use. So if I save and now run the wait, let me just assign text. Text is equal to oops, I forgot the import button here, import option. So from Tkinter import ttk and so on. Yeah, it's now working. So I'll be using the grid method for the labels here, but for now let me create the header frame. So let me focus on the header frame and create 3 labels inside it. So in order to create a frame, we know it's self dot, I'm going to call it frame header, and ttk.frame, and this is going to take self.master. So this frame is going to be inside this root window, which is master here, and I'm just going to do frame header.pack. Okay, since I have the frame header ready, let us just have a look at the layout real quick. So we have the frame header, and inside the frame header we have 3 labels: logo, header and description. So let's just implement header and description labels for now. So I'll just copy the labels from here, and yeah, just these. And right off the bat you can notice I've used the grid geometry manager. So there are 3 types of geometry managers: pack, grid and place. Grid and place provide more flexibility, but place demands exact coordinates like 200, 200. It will just place x and y coordinates at the widget at the 200, 200 place. Whereas grid can also produce complicated structures, but it's more organized and easy to implement. So we'll be switching between pack and grid. Flames will be using pack geometry manager, and labels will be using buttons will be using grid geometry manager. But if one window contains is like for example, if self.master contains frames, that one frame contains pack, the other cannot be grid or place. It should be evenly the same. So the frame should all be pack, or either they should all be grid or all be place, and so on. So I'm going to be using frames as packing and other widgets as grid. So I then can have, even though I have pack here, I can have grid for the contents inside the frame as well, but not the other frames. The other frame should also be following the pack geometry management. So I'll just change the column to 0 here and also 0. So I'll explain it in a moment. I don't need the row column span. Okay, so right now what it says is I have a label widget at row 0 and column 0, and by creating a new row I give it row equal to 1 and column 0. So if I run it, you can expect it to be exactly like the pack geometry manager, because we want it to stack array vertically, right? But if I give them in the same row and have it in a different column, for example. Now you can see they will be stacked horizontally, right? And even I can have a bit more complicated. I have this row 0 column 0 and this one in the row 1 column 1. So you can see that it has 4 sections. So this one is row 0 comma 0, row 0 column 0, and this one is row 0 column 1, and this is row 1 column 0, and this is row 1 and column 1. So as you can see, it's quite easy to implement these kind of structures. So you can imagine it as exactly like a table, and it will exactly do the same functionalities. So I'll just have it in a different column with a different row with same column, and yeah, I'll add the logo. I'll add the logo later. So now let us just go to frame menu. So our next part of the layout, we have finished header except for the logo, and I'll add it after I finish the frame header. Frame menu. So let me just copy the frame menu. So this is the frame menu. Yep. Okay, so exactly I created it the same way I did this, plus I can have additional configuring options. I don't want this for this one, but I can show you how it works. So I'm just going to configure additional properties for the frame menu. So relief equal to ridge. Let me import ridge and explain it in a minute. Yeah, I don't have any contents yet. So let me just copy few of these contents. These are buttons, and I don't need the buttons for now. Just copy these. Okay, so if you can notice, this frame has some different kind of border, and it will be quite outstanding from the other frames. So it is provided by configuring the frame. So after packing the frame, I use the config on that, and relief equals ridge. There are many types, like I can use groove. So let me import groove here, and it will provide a different type of frame border. Yep, it's quite coming upwards, it's not sunken completely. So there are many options like sunken and so on. I'll just stick with ridge for now. Padding is just the spacing between the frames. So inside this frame menu, I have 2 labels. So let me just change to buttons. So I'll just copy all of it. Yeah, I do need to change this to menu. So let me just change it real quick, because I have it as frame body in my other code. Okay, so let's open the application now. It should show error, upload action. So since I have copied the buttons, I gave callback as self.upload action, self.crop action, text action 1, draw action, and so on. So I need to create functions of these here inside the class itself. So along these lines, def init, I'm going to create another function called def upload action, and it takes self. So I can just have an empty function for now, but the point is this function should exist. So let me quickly create all of these commands. Okay, so now we have a frame header and a frame menu that is like this. So right now these buttons don't do anything, but it's just a front end. So now I'll just add the logo here. I did not implement the logo there because the logo is quite big enough and it will not be visible until the application is ready. So if I run now, I should close this. Okay, the logo is, I did not add a logo there because there was no space for the logo to even exist. But since I created all these, the logo now has some space. Okay, so yeah, I can reduce the logo size further. For example, as the numbers get large, the logo size will be reduced. Yep, there you can see it's quite up to the point. So let me just provide you a quick recap of what we've done so far. So we have a master window and it contains frame header, two frames for now, frame header and frame menu, right? And this frame menu and this frame header contains 3 labels, and logo, welcome text, and some information. And we have another frame menu. I just configured this to be standing out than the others, and it has like 10 buttons here that says upload an image, crop an image, add text, and so on. But the problem is we have to provide a command to buttons. So what should happen when the button is clicked? So while doing that, I should provide a function name, and since it is a class member function, I should use it self.upload function. And one thing to know about functions is, while giving it as a command function, we should never call the function like this. We should only give the name of the function and then it should reference here. So if we give like this, what happens is when we open the program, this function will be executed and this function will be like command will be assigned nothing. But if we give this command takes this function but executes this function only after the button is clicked, not before any other thing. So that's an important thing to notice here. But yeah, and since the function cannot be, this function should be defined, so I define a lot of empty functions for it to be valid. So let me just show you. So we provided this. Right now it does not have functionalities, frame header and frame menu, and yes. So up next we'll be implementing these 2 frames. Now let's quickly finish the other 2 frames here. Actually there are 3 frames, but the canvas is not actually a frame. So let me just copy the footer frame from my main.py. So okay, this is the footer frame, and let me just copy and hit paste here. Okay, so this is going to be, the frame is going to be inside the self.master. So this is the frame and I'm just going to pack it, so it means it just stacks vertically like we did here. So it's just, this is a frame and this frame is stacked vertically, and if I do this frame, so the apply and cancel frame will be stacked at the bottom. So this frame contains 3 buttons: apply, apply and cancel, and revert all the changes. I mean, apply, cancel, and revert all the changes. So let me save and see how it looks. And if I close this application, has no attribute apply action. Oh, okay. So yeah, I need to define the functions as well. So let me just keep it here at the bottom. Okay, so as you can see, this is stacked, but I think I would love these buttons to be in a horizontal way. So let me just quickly change it. So I can do that by having them all in the same column. So I don't need this. Yeah, I'm not going to configure the button anyway, so I'll just have them without saving the button. So I have a button and I directly use the grid method on it. So I do need to have them in the same row for them to be vertical, but I just need to change the column. Here you can see a new property, sticky. So sticky means in which direction the button should actually kind of stick towards. So southward means the button will lie to the south side and in the west direction, which is the left direction. So if I save and run it now, oh, I did not change. So actually, row 0 column span equals, yeah, I don't need the column span. Yeah, there you can see. So what column span did was one button took the column of 3 columns. So this button took 3 columns, and this button also took 3, and this button also took 3. So this the last button kind of overrid all the buttons. It is still there in the background, but this text appears to be in the front. So as there are only 3 columns, there are no other columns to be for the other buttons to be seen. So that was the mistake here. So let me just revert, and yeah. So now we do have the frame header, frame menu, and the footer menu. So we just need a frame canvas and a frame submenu. So what we are going to do is, so I'm just going to be using the frame column here, so the frame canvas. So in order to create a canvas, we just need to use this syntax. So let me just paste the canvas here. I'm just going to be this. So this canvas is going to be inside the frame menu. It's not a separate frame. So it is in the same frame as all the other buttons here, all the other menus. But what's the difference is, it is in the column 1 and row 0, and it takes the row span of 10. So I have 10 buttons here. These buttons are total up to 10. So, and also I have all these buttons in the same column, which is the 0 column, only the row differs. So in order for me to have a canvas here with the size of all these 10 buttons, and to the right side of this frame, I just need to add the frame canvas to be at the row 0, so it's the starting point, and it should be at the column 1 with a row span of 10. So it just takes the column of 10 rows, not more than that. But we are going to change the frame canvas itself to be height of 400 and width to be 300. So as we know, most of the images are going to be portrait or landscape, but it is actually dynamic. We can also have portrait and landscape images, but this is the fixed height for the canvas. Okay, so by that I mean, as we upload different images, this is the maximum size the canvas is going to take. So if I save and run it now, let me just close it, and there we go. Canvas, I need to import canvas here. Yeah. Yeah, there we can see the canvas. So it has a fixed height and width, and the row span, which is the 10. So as you can see, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's not going more than that. So this is the fixed height of the canvas. So let me just show you what happens if we have a row span of less. The buttons become quite messy. But the canvas is going to be fixed anyway. I just need to close this. Okay. Yep. So what happens here is the canvas is fixed, but this button, since I have row span of 8, these buttons are going to be just 8. So the 8 of them are aligned in the same as the canvas, but these two buttons, as you can see, it's just the spacing has increased relatively, but these two buttons are not, because the row span was 4. So if I change it now, you can see they all will have equal spacing, and that's the beauty of it. So right now we have actually 3 frames. Canvas is not a separate, it is just a widget. It is going to be inside this frame. So in this frame I have row equals 0 and column equals 1. Row equals 1, row equal to 1, 2, 3, 4, 5, column 0 and column 1. So that's the difference. So now we have the frames ready. We just need to implement the side frame. We have the canvas and the main frame and the full frame. So I just copied the side frame, and you can see I have relief equal to groove, which just highlights this frame from the rest of the frames. So I just need to import this groove attribute here. So just need, it is in the same class as the ridge family, so I just need to import groove here. Okay, so if I save and run it, we may not be able to see anything because we don't have any kind of buttons here. So I can have a label that says tk.label self.sideframe upload an image. So this is going to be by default, because first the user has to upload the image. So I'm just going to show this information. Column equal to 0. Yeah, that should be fine. And yes. Yep. So it now says, as you can see, this frame is kind of different from the other frame. So it's not sunken. It is not in a ridge fashion, but it's a groove. It just brings this frame kind of upwards. So I just need it for differentiation, and that's it. So yeah. Right, so what I need to do is, these other frames are going to be same throughout the application. So whatever button I click here, the header frame won't change, the footer frame won't change, the canvas, the image is going to be changed, but these all doesn't change. So the only thing that changes in which button is clicked is the submenu. So I just need to, for example, if I click on apply filters button, I just need all the other options available for this particular button. And if I change this blur or smoothing button, I need to change this that says what are the options that are available for this kind of button, and so on for the other buttons. So this is going to be dynamic, and since we are having a single window application, meaning if I click on adjust levels, a separate window is not going to appear asking me what values do I want for the for the image. So everything is going to be in a single side, in a single frame. So what kind of actions we need to do for it to pay the price that we did not use the separate images? We just need to forget this frame every time a click on one of these buttons has appeared. It's because this button is probably going to have a different set of options. So if I run the main program, it'll be easy to see that main.py. Yep. So I'm just going to upload this work image. So no matter what I choose in this side, everything else remains constant except this frame. So since we are having a single window application, we are having this kind of trouble that we just need to forget this frame every time the application runs. Let me just clear it. So in order to do that, we just need this option here. So I'm just going to copy this and paste it in the demo section. Okay. So in all of these buttons, I need to call this function. So this function, what it essentially does is, I would have created this side frame anywhere. So if it tries to forget, meaning the frame has not been created yet, it just erases the contents of the frame and it creates this. You can ignore this code for now. So this is the only piece of code. So what it does is, every time I call this function, it tries to erase all the contents of the side frame if there is any, and then it will try to create a new side frame every time. So that's kind of how it works. So we just need to call this here, refresh side frame. Yeah, we just need to use it self because it's a member function. So inside it, let me just have a label that says self.sideFrame and text equals please upload an image. So I'm just going to copy this in the same in different button action, and this time I would say please enter a text. Okay. So as you can, if you remember, these are the two actions that are corresponding to the main menu: upload an image, crop an image. So whenever this button is clicked that says upload an image, this function will be executed, and whenever the add text button is clicked, this button will be executed. So if I save and run the demo program, if I click on this, wait a minute, frame menu. So if I click on the upload image button, a new frame is created, and this is again, and this submenu is then updated. So if I click on this, it says please enter a text, and you can see no other thing changes. So the only thing changes is this frame, but the window is not, it's kind of moving. It's because the frame is not created and the text content varies. We can have a fixed window later. It is already fixed, but we just need to have a bigger image. So yeah. So in this side frame, we are just going to implement all the button actions. For example, filter button contains So filter button contains, I just need to upload an image. All these options inside it. Blur button contains all these options. Adjust level, yeah, and so on. So we just need to add all of these, and let me just copy all the code from it real quick. So filter action, and yep. So I'm just going to copy the filter action, and we do have a filter action button here. So I'm just going to paste it here, right? And voila. Blur action. Okay, so now I do have the buttons inside the side frame. So if I click on filter button, this is what happens here. So I just quickly need to give all the corresponding values here. So negative action. So let me just quickly create all these dummy functions for now, and then let me explain the code. Okay, so as you can see, now I'm just going to need submenu for these 5 buttons to be specifically. So I have all the buttons here. So in order for all these buttons to actually render, I just need to give the command, for example, negative action. So that's why I have these dummy buttons, for which I'm going to later have the options, for example, the OpenCV kind of the backend. So what now is, if you remember, there was a slider here. So for blur, there was a slider to actually render the values, to actually select the values from the slider. So I did not import the slider, so that's why it's showing me errors. So I'll just fix it quickly. But you can see the other submenus are working fine except these two. So scale is not defined, so I'm just going to import. Okay, so I'm going to import scale now. I mean, you might ask that if ttk.label is available, why do we need to import scale? Why can't we use ttk.scale? Actually, you can. There are, I mean, ttk has separate sections of widgets, and Tkinter has them separately. So if I use them, there will be different kinds of scales. So if I just use ttk.scale here and a normal scale here, let me just import horizontal for now. Horizontal. Yeah, horizontal is a property we are going to use it inside scale, so we just need to import it. So let me just show you a quick difference of how a scale might look from ttk.scale versus Tkinter scale. So okay then. Yep. So this is the slider which is without Tkinter, with ttk.scale, and these are without ttk.scale. So ttk.scale, both kind of have same functionalities, but I prefer using scale from Tkinter for this project. So I mean, it automatically adds the value here. So these kind of add-ons we do have from scale. So I am going to edit import scale, and I just need to change this back to. So you might have noticed for the buttons I did not save the button variables and use them later, but I might need to have these scales values, because when I just use the callback function, so this is a callback function. Inside the function I will be using the average sliders value. So what's the value the moment after the slider has been changed? So in order to access the value, I need to have this variable. So all the other scales, I just save the variable and then use the grid method on the variable instead of like this directly. So that being said, let me clear it, and yeah. So we have all these types of functions here, adjust buttons and so on. So our front end is kind of ready. Now we just need to develop the backend for it. So okay, so before going to the front end now, before going to the backend, I would quickly like to discuss about the front end first. I mean, in order to get a strong grasp of what we really have done before we move on to the backend. So we follow the basic architecture with one exception, that we do have frames, and this is the header frame and this is the apply frame in which we have like a footer, and this is a single frame, and we have one grid system here and the canvas in the second column, and another frame inside this frame. So we do have 4 frames actually, but this frame is embedded within this second frame. So we have scale. So I did not explain scale very much, so I'm just trying to explain scale in this video. Okay, so as you can see, we do have this is the label, we can ignore this. So I have assigned a variable to this scale, and I've set the from value from, and this underscore is really important because Python has a keyword called from. So in order to avoid the confusion between this, as you can see, this keyword, we have used an underscore before and after the from, sorry. So and likewise, in order to follow the same convention, we added an underscore here as well. So this is the initial value of the scale, and this is the maximum value that the scale can occupy, and the resolution is what says in which increments the scale should move when we are adjusting it. So if I go to the brightness section, if I adjust it slowly, it will increment by 0.1, and that's what exactly I am saying. And orient equal to horizontal means that this is a horizontal scale. We can also have a vertical scale, so but I stick with this scale. And command is just a callback, so whenever the slider is moved, like it will call the function now. So if I can show you this, is it now shows an error because I did not set the function arguments well. For example, if I just use this filter, so just notice when the function will be called when I adjust the slider. So as soon as I move, the function is called. So if I move fast, the function is called multiple times, and that's how it works. So initially, the brightness, if I set the brightness scale to be 0, by default, every scale starts from 0, because I mean not from 0, the from value. But in this case, if I do give the brightness of 0, the image will be pretty much dark. 1 is the exact scale. So I do need to set the brightness scale to be at 1 by default and the saturation by 0. So when the saturation goes negative, it will just enhance the image, but the original image stays at 0, and as well as for the brightness it's for 1. I could have done something like adding 1 to 0. For example, I could add 0 here, so the scale to start from 0, and then I can add +1, so that the image, whenever by default it will be added +1, so that I can start the scale at some other point, but I just want to be consistent. So for that, I just set the brightness slider to be set at 1. So after this widget has been created, we are just setting this brightness scale to be 1, and without saving this variable, we couldn't have possibly set the brightness scale to 1. So let me just walk you the code quickly one more time, and yeah, I just need to make this give this window a better appearance. So I'm going to give it a title and a defined width. So what I'm saying is, the window is going to take 750 width and 630 height. So if I save it to be 30 here, and if I run it, you can see the height of the window is too small. I just need to maximize it to have it like this. So this is the width of the screen of the window, and this is the height of the window, and this is the offset. So offset means from the screen we have like 250 pixels wide, and from the top we have 10 pixels wide. So now it may not be, yeah, I did not save it. So the offset is 10 pixels from the top and 250 from the bottom. So we do need to give a plus symbol here, and the whole thing as a string, and the title is what gives the title for the app, so we can have it. Okay, so moving on to the frames, we have a frame header, which is this, and we have 3 labels inside it, a logo and 2 of these. So we have used a photo image to have the logo and 2 other labels, and the frame menu is these guys, is these options. And yes, so I do have a configuration here in order to make it look beautiful, and inside this frame menu I have 10 buttons, and these 10 buttons I have a callback function, but they don't do anything much for now. And then we have an apply and cancel frame, which is this. So as you can see, this window now stays quite even, so if I just use this, it's not kind of overlapping the screen or anything. So this frame contains 3 options, 3 buttons, that's why I have it here. Okay, so since this is the most important part here. So the frame menu this frame is already being managed by grid system. So what I mean is, I have frame menu, I've packed it here, but it's not the point. What the point is, inside the frame menu, every button uses the grid geometry manager. So this button is inside frame menu, and everything inside it uses grid. But if I try to use pack or anything for this widget, it will throw an error. So this happens in most of the cases when we are not aware of the grid geometry what we are actually building. So what it says is, so we already have a frame, and inside the frame we have a pack button here, a pack geometry manager. So whenever it sees grid, it says, wait, that's illegal, we already have pack geometry manager. So if I say grid, that doesn't make sense, because what we have done earlier is what it counts. So we just need to have everything as grid. So likewise, this frame menu also contains this canvas, right? So this frame menu contains these buttons, so these are all managed by grid, and this frame menu also contains this canvas, so it should also be managed by grid. And also likewise this frame should be managed by grid, but this can be managed however we want because it is not directly related to this frame, but these buttons are inside this frame, so everything inside this should follow either grid or pack. So that's why we have to carefully select that. Since we have all these buttons managed by grid, we have to also manage this canvas by grid. And also here we have a side frame which is inside the self.frame menu, but we did not pack this frame. We've used grid system here. But the main window self.master contains all the frames taken care of by the pack. So we have a frame header taken care of by the pack and frame menu taken care of by the pack because it's being used by self.master, and also the frame footer which is also taken care by the pack geometry manager, but not by the because of this self.master. But since we have the frame menu having the buttons as grid, we do need to follow that these buttons should have the grid, and also as well as the other canvas and the sub menu here. So that's literally quite about the front end. So we just need to trigger the button clicks, and there's a few other things that we should care of. Uploading an image, it'll take probably 2 minutes to explain, and cropping an image we'll see, or it has the final part of the series. And up next we'll just implement these basic operations: applying filters, blurring and smoothing, adjust level rotation. These should be fairly easy. So up next, let us implement these actions. Okay, so now we are going to implement the backend once. So what we're going to do is, now we're going to upload an image. So whenever I click on upload image, a dialog box would appear, and if I select an image, it would appear in this canvas. So that's what we are going to focus on now. So let me just quickly show you. Let me just quickly copy this code from here and explain it over there. Okay. And also the upload action. Okay, since we have covered the OpenCV tutorial in the previous classes, this should be pretty easy. So I'm just going to search upload action. Fine. Yep. So let me remove the old dummy code and paste it here. Okay, so in order for these to work, I need to import these things: file dialog, import cv2, and from import image tk. Okay, so if I save and run it, this should work. Right, so let me now focus on its working. Okay, so before we upload any action, so we are just deleting the old canvas. So the old canvas contains some gray background, or we are just overwriting any image if there's anything. So first we are doing that. And so since I included the file dialog from here, so Tkinter provides an easy way to open the file dialog. So we're just going to use file dialog dot ask open file name. So similarly, we have file dialog dot ask save as file name. So this is going to open the save as dialog box. So when we are just saving the image, we are just going to use this one. Pretty easy, right? And what it does is, it just saves the file name of the file, nothing else, not the image, just the file name. So if you are going to print it, it will just print the exact file name with the extension. So, and using OpenCV's imread method, we are just passing the file name here, and this image is stored as the original file name here. So this contains the image, and also I have other three images, other three variables. So original image, edit image, and filter image. All the three are same initially, but as I edit, this edited image is going to change, and also the filtered image. So that will be implemented later, but for now what happens is, right after the image is uploaded, we're just going to read the original image, and this image is passed, or any of these images passed to this self.display image. So this is a custom function that I've just copied from it. So what it does is, it accepts an image as an argument. So if I go down here, right here, yep. So by default, if there is no image, if I didn't pass any image, I'm just going to show the recent edited image. So as usual, I'm just going to delete the canvas before displaying the image, and also this block provides some kind of check if the image is, if I pass the image. If not, it is going to show the recent most image that I've used. And now this option is kind of important, because by default CV2 operates in BGR mode, and as we know, we are used to images with RGB. If I don't provide this option, the colors are going to be kind of inverted. The green and the blue and red are going to be changed. So if I run it and upload an image, as you can see, this is not the perfect image this is not the original image. So we do need to convert this BGR type. So because whenever I use the cv2.imread, it has the format of BGR and not RGB like we are used to. So we need to use the convert color of the OpenCV library, and we are going to pass the original image which is in the BGR, and we are going to use this cv2.color BGR to RGB. So this converts the image to RGB format, and we are storing the new image here. And now what happens, we are just going to get the details of the image. Channels, we won't be needing it for now. So image.shape contains height, width, and so in order to calculate the height to width ratio, we're just dividing it, and we have the ratio. So the important thing is, the image may not be to the size that we are expecting it to be. So we have a fixed canvas. So while I created the canvas, I had the height as 400 and the width as 300. So what happens if the image does not fit within these height or width? So we're just going to resize them, and that's exactly how it's being done here. So first we just need to check which of these conditions are being changed, right? So by default, we provided a height to be 400 and width as 300, which means that the height to width ratio will be greater than 1. Since height is greater than width, it should be greater than 1. If it is less than 1, that means that the width of the image is larger than the height. So whenever the denominator is greater than the height, the ratio will become less than 1. So if this condition hits up, we're just changing the new width to 300, which is the exact canvas width that I have provided. And importantly, we also need to adjust the height of the image. So even though we made the image width to be fixed, in order to get the perfect aspect ratio, in order for the image not to be clumsy, we need to have a height according to this width. So a height according to a width. That's what we are exactly doing here. So the ratio contains the height and the old width. What you are trying to do now is, we just have the height, but the width part and the new width part are gonna get multiplied, or they are in division mode. So as a result, the new height is going to be the new height is going to be reduced than the original height. So we are obviously reducing the new width here, because if this condition is satisfied, the width is higher. So we have a higher width in this variable. So we are just reducing the width. So if we reduce the width, we also need to reduce the height in the same way. I mean, in some way, in some fashion. That's what exactly the formula does. Height according to the width. So if the height condition fails, if the original image height is different, we are just changing the height to be contained within the canvas. So we are just reducing the height to 400, and also now as the same way we're just changing the new height. So new width, sorry. So if the height is reduced, the width should also be reduced. So I hope that's clear, and we're just using the new ratio. So this I will explain later. So this, what it does is we are just computing the height to new height, meaning how much the height has been changed. So we will be using this in the cropping functionalities and so on. So we won't be needing this for now, but just let it be for now. And then since we have computed this new height and width, either we are going to end up using this new height or width or this. So since we have calculated it successfully, we're just going to resize the image to fit in the canvas with this new height and width. So we are just going to provide a tuple, and this tuple, the first argument is the width and the second argument is the height. And if this condition fails, we have this old height, this original height, so nothing's going to be bad. So this new height and width are going to be resized, and we have a new image here. And we are just using photo image to convert this new image to properly read for the Tkinter. So we have an image TK library, that's why we imported it. And now what we are going to do is, we are going to configure the canvas newly. So since we have deleted the old canvas, we need to configure according to the image's height and width. So we might have images which are kind of portrait or landscape. So if we have a landscape, we cannot use the canvas. So the canvas is just to fill the area, but the actual canvas is just going to be configured for each image, right? And also I've shown you in the demo while working with OpenCV, we are just, while creating a canvas image, we will divide its width by 2 and height by 2 in order to have a good center position around the image. And we will just pass the image as the attribute here. So, and as a result, whenever we run this, the uploaded image is the JFIF format is saved in the file name, and we are reading it, and the canvas shows the image. Okay, up next we are just going to implement the filters and the blur options. Okay, so let me add a few comments here to explain what it's exactly doing. So self.canvas, I'll have it, destroys the old canvas widget. I'll have it in a single line here, and yep. If image is not passed, we are going to show the recent edited image, which may be the original image if we have not edited anything. Converting RGB BGR color scheme to RGB for Tkinter canvas to render the image properly. And here in this section we are just if the image size is greater than the canvas, we are assigning new height and width to the image. We are not actually, we are assigning, but in this step we are actually converting or rather resizing the image to new height and width. Alright, so yep, that should do it. So now what we are going to do is we're just going to implement all these rotate action, rotate right action, vertical action, and so on. So we have already created these buttons, but right now they don't do pretty much anything, so we're just going to replace them. So first, let us start with the filter section. So the filter section contains, let me just copy. So it's going to be pretty easy. Okay, so this is the negative section here. So if I just copy it, and I'm just going to paste it here. Okay, so what we are going to do is, we have, as we have seen, we have 3 types of images when I use the upload action. So okay, so we have original image, edited image, and filtered image. So the edited image is quite the most important. So this is the image that is saved after the user has applied the click the apply button. So the filtered image is the temporary image. It means that the user did not save the image while he was browsing through the filters, but when he did choose to apply the changes, we are just going to save it in the edit image only after that. We are not just going to save the filtered image, but it will be shown in the canvas every time the user is going through. So for example, I'm just running the main file here. Yep. So if I upload an image and if I go to the filter section, so as you can see, if I apply negative, all these changes are actually being updated in the canvas, but when I just switch over, we see the original image, meaning that the user did not select any of these options, that he was just browsing over. But if I apply one of these, for example this action, and if I go to this option, it will be staying in the canvas. That means that the user has probably wanted this action and he wants it to be saved. So that's why we have these 3 types of images here. So what we are doing is, we are using the edit image, so we want the recent copy of the image. So that's the edit image, but while we are saving it, we are saving it in self.filtered image, not self.edit image. That edit image should be saved only if the user has clicked the apply button. So it will probably be used in the apply button action, but not now. So yeah, so right now what we are going to do is, cvt.bitwise not is a negative function. So whenever there's an image, we are just negating the bits of the image, so that ends up giving this negative effect as we have seen earlier. So this is the negative effect, and that's what exactly the bitwise not does. So that's it. In one line, the image is actually processed, and we are just showing it in the self.filtered image. Likewise, we have a variety of buttons, variety of options here. So let me just quickly copy them and show you that. So filter button actions, here we are. Okay, we saved that already, and yep. Okay, let me just walk you through this quickly. Some of them do have some mathematical calculations, but yeah, they're kind of dwell into the image processing functions. BW is also self-explanatory. So CVT color, so convert color changes so right now we have the image in BGR. Remember, we did not convert it to RGB because we do have the filtered image as BGR only. Only while displaying the image, we are just changing it to RGB. So right now the image is in BGR. So there's this attribute that we can use, color BGR to gray. So gray. So all the BGR will be mapped to gray levels, and the image will be displayed. And stylization is kind of same. We do have two extra parameters. So sigma S and sigma R controls the stylization. So it's kind of like almost like a sketch effect, but with a different one. So sketch effect. So while we are working with sketch effect, we do need to have another return parameter here. It's because it returns two values, and if we try to use this in a single variable, it will just save it as a tuple, and we won't be able to get the image out of it. It will probably show some unwanted behavior. So what it does is, so we just need to have a temporary or a throwable variable here. So, and what we are going to do is, we are just using the editor image, and we are just have some pre-computed values here. So sigma S 60 and 0.5 sigma R. So these are all some image processing stuff. We can just play around with it, probably give some scale to the users for them to play around with, but I've just used the button, so the user does not have any flexibility over this option. So we have just the pre-computed values. So this is the sepia and the emboss action. So what we are just going to do is, we are just having a kernel here. So kernel is kind of like a mask that's going to, so it's a matrix. So we have a 3x3 matrix. What it does is, it just goes over the image line by line and change all the neighboring pixels accordingly. So we can select any of these functions. So right now it's like an 8 neighbor kernel. So we're just using the self.originalImage and passing the kernel to it, and it will just probably use it. So filter.2d. So if we have a different kernel, so these are some kernel values for sepia function, and it will just compute the original image. So right now it's just all the tinkering with this kernel values, and likewise there are 3 other options. So we should be careful about the return value here. So it's not kind of intuitive to actually think about these return values. So right now we are just using the CV to the threshold, and we are going to provide, so at what value we do need the threshold and what's the maximum value it's going to be. So this is how we actually give it. So this correspond to 8 bits here, and we are just going to have, whenever there's a value of, whenever we don't need to give it as a threshold of the middle value, so it will just kind of convert it into a map value. So whichever values comes under 127, it will just map it to one value, and whichever value comes above 127, it will map it to another value. So it will just convert it to 2 major values, and which is exactly a binary thresholded image. And erosion, we are just having some kernel. So we are just having an array 5x5 matrix containing an array full of ones here, and then we are just passing the kernel to this erode function, and the number of iterations is in how much time this kernel is to be applied, and we are just giving it as 1. Likewise for dilate, it's just the same. The only difference is the member function that we are using. So if we save and run it, it should be fine working with these filters. So negative, black and white, stylization, sketch effect. Oh, okay, so I do need to import numpy here. np, I do need to give a space. Okay, so yep, that should do it. So right next we'll just take care of the blur functions. Let me just copy the, yep, this is exactly the blur. Okay, so yeah, I'm just going to override these and voila. Alright, so these three functions use the scale values. So there are many types we are actually going to use these scale values. So first I'm just going to use the value provided by this by default. So what happens is whenever I change the scale, it returns an event. Okay, so in our case, the event is just the value of the scale at which the slider or the scale has been moved. So I'm just going to get it as a value. So by default it's a string, and I'm going to need to convert it to an integer. So how the average works is you just give it kind of a matrix. So we just give either a square matrix or a rectangular matrix. So that matrix is going to be probably an odd matrix. So it's either going to be 3 cross 3 or 5 cross 5. So we do need to check if the value is going to be an odd or an even number. So if it's an even number, we just increment it by 1 to make it an odd number, and then we are just passing this this value, which is a square matrix in our case, and then we are just using the blur function, which does everything for us. And these other options are also similar. Gaussian blur also accepts these two values, and this is another parameter that we can control. So yep, value, int value. So we're just changing the int and we're just doing the same operations. The only difference is the Gaussian blur function. And median blur also has, but this time it is definitely a square matrix. So we're just getting the image, making it as 1, and we're just using it. So but here it can be a rectangular matrix, but here it is going to be a square matrix, at least in our case. So I'm just going to print the value and also type of value. So I'm just going to check the median action here. So if I run the demo.py, let me just upload the image and adjust levels, no, blur image. So as I change the slider, you can see the value appears here and its class is a string. So that's how we do it in one way. Okay, so there are other ways to actually get the value of it. So I can say value equal to self dot, we just need to median blur dot get. So what it does is this function actually, let me print it again, type of value. Okay, so this is it. Well, median blur. So what's the name of the slider? Median slider. Yeah, I just need to have a good naming convention. Okay, so as you can see, this exactly works the same, but the class is of type int. So it's actually quite better to use a get method, but it's also not bad. It's actually the same result, but we just don't need these extra steps of converting it to an int. So I'm right now in this set of actions, I'm just going to get it as a value of string and then convert it to an integer, and after that we are just storing it as an odd number. So that's how the averaging, Gaussian and median actions work. So let's move to the brightness and other scales. So we have brightness and saturation scales. So it is exactly the kind of the same, with it doesn't have much difference here. So yep, I'm just going to override them here. So what it does is we are just using this cv2.convert scale to APS. So what we are providing is alpha value as the get value. So I do need to have this second value, because while the function is actually called, it expects the second argument. So even though we don't do anything with this, so we just need to have it as an event. So when the brightness action is called, it gives the set of values, but I am going to get the value of the brightness slider as an int directly and pass it to alpha. So this alpha actually indicates how much of the brightness that we actually need. So when alpha equal to 1, I mean this is the same method, but the saturation uses alpha equal to 1 and beta as its changing parameter. So if I have some alpha equal to 0.1, it will start with a darkened image, or if I have something like 1.5, it will start with a brightened image. So it is the variable here, and beta is the variable here for saturation. Okay, so let's test it. Yep. And yeah, adjust levels. So since we have the brightness scale set to 1, it is starting at the middle. Yep, I don't need these much of values, but that's what I give. So saturation takes actually minus 200 to 200, because that's exactly what the value I gave it in here. So it starts from 200 and it ranges from minus 200 to plus 200, but I have set the saturation slider to be at 0. Like it's not a default, but as soon as the widget is placed, it just sets the value manually. I mean inside computationally, but not exactly. It does start from 0. It starts from the initial value, but after this the widget has been placed, it just sets the value to 0. Likewise for the brightness scale. So I have a resolution of 0.5 here, which can be anything you want. So we just applied 3 of these. Right next we are just going to implement the rotate and flip actions, which is going to be similar as well. So these are the 4 options here. So I'll just override them here. Okay, so I am going to exactly document which section corresponds to which of the actions, like these. But for now we're just going to use section wise, so not a problem. So the rotating actions are quite similar and self-explanatory as well. We're just going to use the rotate and the flip methods of the OpenCV. Okay, so rotate has like rotate 90-degree counterclockwise, 90 counterclockwise, and rotate 90 clockwise. So what it does is whenever I click the rotate button, it just rotates to 90-degree clockwise. I mean the rotate right action. The rotate left action rotates it to 90 counterclockwise. And flip is kind of the same, but we're not going to have anything like this. It is going to provide an integer. So 0 means it's going to have a vertical flip. So from left to right, and the horizontal flip just rotates from like top bottom wise, and that's it. So if I just save it, so vertical flip rotates this and horizontal flip just rotates like this. So since I do have to save it every time for it to rotate like this. Yeah, it's because I'm taking the original image, I mean the edited image, and not the filtered image. So if I have the filtered image here, it'll be a bit different. So because like the recent edited image I changed was the image it was working on, but we do need to have instantaneous kind of checks. So we need to have this. So as you can see now it's rotating. So now it's making a full turn of the image. Okay, so yeah, since I did not have any action for the apply button, it did not actually save the image. So for me to have the instantaneous results, I change the filtered image. So yeah. Okay, now let's quickly implement the apply actions. So this is the one. Where did it go? Okay, so what we are going to do is, so there are three kinds of states for image, as I said: original, filtered, and edited image. So the edited image is kind of like the final copy, and the filtered image is going to be the temporary image at which the user want to apply the filters. So the user might have selected a filter and it shows in the canvas, but he might not save it. He might scroll to other options, and that becomes the filter image and not the edited image. So what we are going to do is, whenever the user clicks the apply action, the filtered image so far becomes the edited image, and now we are just going to call the self.display image for that to be updated in the canvas. So as you will see, for every other actions that we did in the filters or in the blurs, we did change it, we did call the self.display method and called the filtered image. But we are just going to save the filtered image to the edited image only after the apply button is clicked. So till then the filtered image is absolutely temporary. The user is not saving it or is not applying the actions. So if he just refreshes the other options, it will just probably bring back to the original image, which might be the edited image. So apply action does exactly that. It takes the filtered image, that is the process that has been taken, and makes it kind of like a temporary image. And the cancel button, so cancel button, if there's a filtered image on the canvas and the user wants to see the last recent changes that he had applied, he would like to see the self.edited image, which is the recent changes that he had made. And the revert action just edit it and just deletes all of these contents of the edited image and makes it as an original image. So copy is kind of important, because so if you are good with, if you are new to Python, the copy is going to be important when you are going to change, because the image is actually an array, and whenever you, it's a list actually, so whenever you just assign it without the copy, whatever changes we are going to do with the edited image, not like this, whatever we are going to change with the edited image also affects the original image in a strange way. It's because deep inside Python, these are not variables, everything is just a reference. So we have a reference, and the whatever we change it in the reference will be affected everything that uses. So in order to have a truly copy, we just need to have this copy method. We do have something like deep copy as well, but we won't be needing it in this project. So that's how the original this works. So if I just run it, we can see we have an image, and if I have negative, the user can cancel to bring back to the original image, for example this. But if we apply it here, so whatever functions I go to, the canvas is just like this. So when you click on save as, this image will be saved, not the filtered image or the original image. So revert all the images, bring back the original image. So up next we'll just see about the inner workings of the crop, add text, and draw over images, and we'll just finally save the image. We are going to implement a quite complicated backend, such as cropping, drawing over images, and writing text over images. But these three have almost exact same functionality, so just implementing one of them will obviously pave a way for easily implementing the other two. So let me just show you quickly how we are going to proceed. So these are the three options that I have here. So add text has a pick a color font and enter text, so two kind of options, and draw or image just has a color button. So if I open it, I can just select a color and it'll draw it. So let me just show you how a cropping an image works. Okay, let me just minimize this. Okay, so there are three kinds of events happening. First, a mouse, so a mouse is clicked and it is dragged and it is released. So these three events, we're just going to keep track of them, and we're just going to crop it. Okay, so add text also works in a similar way. For example, draw or image, first I'm just going to click, drag, and release, right? So these three are the events. Add text also works as the same way, so I'm just going to click, drag, and release. Okay, so these three of them almost have the same functionalities. So that's what we are going to do now. So let me just copy. First, let's start with draw action. So I'm going to copy this code. Yeah, almost this. Both of these. Okay, so yeah, let me just put them quite at the top here. Okay, crop action. Yeah. Okay, so as soon as the draw button is clicked, what we are going to do is make the Tkinter listen for two events. They are button press and the motion. Alright, so for draw action only two kinds of motions are enough. Okay, so as we know, we are just having a refresh side frame as it. So I do provide a default color code here, so I'll come to it in a moment. So color chooser is what we are going to have here. So we just need to import it as well here. So color chooser is the color palette that enables us to open the color palette we just saw. So color chooser, yep. And what it returns is exactly a tuple. It contains a tuple and a hex value contained in a string. And what I'm going to do is, so as soon as the color button is clicked, which is the draw color button, this function calls this. Alright, so I'm going to save this kind of value. So it's a tuple, and I will save this in the self.color code. So at the end I will use that color. So how it exactly works? So after the color, so we have the canvas and we're just going to bind an event to it. So events can be binded. So there are many types of events like key press, dragging, and double click, and so on. So we're just going to bind canvas. So as soon as the draw button is clicked, we are going to have the canvas to listen on events such as button press and the button in motion. So when the button is pressed, we are just going to call this function, and while the button is in motion, we're just going to call the draw function. Okay, so that should be clear now. So let me just copy the draw and the draw function. So these two are the exact functions, and if I paste them here, okay, so what happens is, as soon as the draw button, the button is clicked on the canvas, this start draw function is called, and it expects an event. That event is expecting coordinates. So we do have many options in that event, but we are just going to get the x and y coordinate of that event. So it can be anything. I can name it whatever you want, but event is kind of conditional and I highly recommend it. So event contains x coordinate and y coordinates of exactly where the button is exactly clicked. Okay, so button press, it just keeps track of it. So we are just going to save it in self.x and self.y and self.draw IDs. So that seems kind of bizarre. So it's just a list. So what it contains is, whenever let me show you. So whenever I just draw over the image, so when I click the button, first the list is initialized, and when I drag it, the list keeps expanding. So it contains the first value, which is 31, and then I'm just dragging it downwards, right? So it contains all the 31, 32, and so on. Okay, so we're just appending the line to it. So whenever I press a new area, it just creates a new list, but when I keep on dragging it, it is the same list overall from here. So this list started from here, and it went all the way across it. So it's just a single list from then, but when I click it here, it just happens to be a new event. Alright, so we are actually, while creating a line, we are just creating, while actually drawing on the canvas, we are just creating a line. So we need 4 points for a line, and mathematically we need only 2 points, but since we are using it in a Tkinter window, we just need to provide the x and y coordinates of the starting point and the x and y coordinates of the ending point. So 4 in total. So we are not actually creating just points, we are actually creating lines. They are very small lines, to be exact. So if you kind of zoom in closely, they are actually small lines that we are creating. If we increase the font size, we'll know, but So we provided the 4 coordinates. So self.x is the starting coordinate. It just need to be initialized one time, but while in motion, the self.draw is going to be appending the new values. So every time the motion is the mouse is being moved, it just records this instant and then appends it to the draws list. So that's how the line is created in the canvas, and to show it in the canvas we're just going to use this cv2.line. So right now it just appends it to the list. Nothing is being shown here, but cv2.line actually is going to draw on the image. So we're just passing the self.filter image, right? And yeah, this is kind of mathematical. So in order to convert it into a small line, we're just going to have it multiplied by the ratio. So we did change the ratio of the, while resizing the image, we'll change the ratio of the image, which because we are just going to resize, and we just need to add the coordinates accordingly. We don't need to go anything like over here the canvas and so on. So we need to provide this coordinates, and yeah, or for all the 4 points. So this is for the first point, second and third point. So xy for first point and xy for second point. Okay, so this is the color, right, and this is the thickness. So this is also, we need to be sure according to the size of the image, the thickness is going to vary, and that's exactly what is happening. So after that, the new point is being saved to the self.x, and new point is being, like, from the event we are just, so for the initial value we just captured this, but as the mouse is being moved we just need to upload this constantly, because everything is reference to the previous point, right? As I said, everything is a small line, so one line needs to be connected with the previous line, starting point of that line, not like 10 lines ago. So if I just do this and did not do I did not do this, it will just keep on referring the first line that it created, but in actually there are hundreds of lines here, so we just need to keep on updating it. So that's how the draw actually works, right? So now let's go to the cropping section here, right? Okay, so this is exactly it. So I'm just going to copy it from here and explain it over there. Okay, so if you would have noticed that while cropping we are just drawing a rectangle here, right? And we are just storing the rectangle coordinates. So rectangle also has only 4 points to be taken care of, x and y for one point and x and y for the other point. So we don't need to actually there are 4 kind of vertices, but we don't need all of the 4 because it's all going to be along the same line. So back to topic. So we are just drawing a rectangle, and the region of focus we are just pass it to the OpenCV and it just crops the image. So how it exactly works is, this has 3 kind of events: button press, button in motion, and when the button is released. So we are going to record the initial coordinates, the starting of the rectangle, when the button is exactly pressed. So we are going to call it self.cropx equal to event.x and event.y. So initially we just assigned it, initialized with 0, and the end crop also has the event, but we are just going to get the crop end of it. So while we are in motion, we are getting all the data from the event.x. So while in motion, at every point there is going to be, while in motion there is a point that is going to be generated every time, but we are getting the latest point. So the self.crop index is going to be taking like several pixels of values, but at the end and exactly just before the motion ends, the last value is what we are focused on. So right now we just have the coordinates for a rectangle. Okay, yep. So we just have the starting point, and the crop is going to be, as I said, there are 3 functions for each of these: start crop, crop, and end crop. In the start crop, we just store the initial coordinates, and in the crop, we are just storing the final coordinates. So all it remains for us now is to create a rectangle in the canvas. So we just create a line in the canvas in the draw function here. Create line. Now we are just going to create a rectangle. So the rectangle is clearly visible while we are just cropping out the image. So this provides the rectangle coordinates. So that's exactly what we're going to do after we start with OpenCV. Okay, so we just created a rectangle with these 4 coordinates that we just stored, and then what we're going to do is just going to remove the rectangle, right? We won't be needing that anymore. So every time that is released, we're just going to remove it. So we can just delete the coordinates of the rectangle. And while end crop, we are just doing actually the crop options, right? So this is exactly what we have at the end, and we are just providing the y and x values of that image. So this image is just an array, and we are just selecting a predefined of values. So assume that it contains from arrays from 0,0 to 5,5, and here we just have something like, for example, 2,2 to 4,4. So we're just kind of slicing the image. So this rectangle array, this subset denotes the slicing, and we are just providing coordinates up to which we want to slice. And that image, which is the reduced size image, is being stored, it's being displayed. It's not actually stored, but it is being displayed. So we have 4 kind of options here. So if self.cropx is less than self.cropy, meaning that the coordinate of x, it's at the topmost corner, and the crop index is assume that it is at the bottommost corner. So right now this condition exactly satisfied. So we're just going to have starting at the top and ending at the bottom. It's because there are many ways to crop an image. For example, I could provide from the bottom, right? So we just need to record which is the starting and which is the ending. So that's what all these 4 conditions does. Sometimes we may be starting from here, here, or here, or from here, or from here, right? So we are just going to get the start x and start y accordingly. So because that's quite important, as we are just relying on x and y, we just need to provide exactly what we are kind of trying to crop using the slicing method, right? So that is the 4 kind of options. So first option, x will be less than the ending, or else it will be greater, while y remains kind of same in both of these. And next, x remains kind of same, but y has the start of y is greater than. Okay, so after getting all these 4 values, in order to kind of crop the image array, so as we know that this is an array, we just need to get the predefined, we just need to get the region of interest using cropping the array, so slicing the array to be specific. So we just need to create a slice object. So we're going to pass the starting x and ending x. so it will correspond to the matrix row and column, and we are just going to slice from as in steps of 1 and until we hit this start y, and then we're just going to pass this x and y exactly in this way. So this will crop the image and save it in the self.filtered image, and we're just going to display it, right? So this is how it is, and writing text on the images is also the same kind of tasks. So what we're going to do is, so writing on text, so writing on text takes two options. So enter the text and the color. Okay, so and it is exactly like cropping, but instead of cropping we are just placing the text here. So this is the crop action, text action. So we have exactly like the crop action method. It's exactly the same. I just copy pasted it, and except this. So instead of having end crop, which is what I had in this, I'm having these two same as the crop action, and I'm just creating another function for end text crop. So end text crop also contains exactly the same conditions. So this is the only thing which differs from the crop action. So what I'm just going to do is, I'm just getting the text in which the input is given. So I'm just getting, let me add an image. I'm just getting the text I'm entered and also the color. So in this value. So and then I'm just going to get the color code, so of whatever color is selected. And what I'm doing is, so this returns some float value of RGB, but I wanted it to be int, so I'm using a map function. So if I print self.colorcode, as I said, it is in the format of, it has a tuple and it has RGB format, and also now it has some X value in a string ff000 something. So I'm going to extract the RGB value here, and for that and for each RGB value I just need it to be an int instead of float. I don't need float value, like it did return me float value, so that's what I'm doing it. So it iterates over these values and changes them into an int. That's what map does. So it takes a function and whatever data we are passing, and I just need it as a tuple. So RGB is what it's going to be. So R contains, so it returns 3 elements. R is going to be assigned the first element, G is going to be assigned second, and B is going to be assigned the third element. And so put text, so in order to write text on the image, put text is a method from OpenCV. So first we just give the image and then the text that we want and the coordinates. So start font is start x comma start y, so it's a tuple. We're just going to provide it like exactly this as a tuple, and we select a font. There are multiple fonts for font Hershey, duplex, and so on, and this is thickness, and this is what I've been telling you. So OpenCV kind of works on BGR format, and that's why I did not provide the self.colorcode directly here. So instead of getting the instead of that, I just assigned the RGB from the color chooser, and then I passed it manually using, I passed the tuple manually, and BGR is what I had. So if we run it, it's, oh, it is in the main.txt, so here. So if I save and run this, So we must have everything working other than the save button. Cropping an image. Oh, let me see. I think I need to import the round here. And I do have multiple functions for crop action. Yep. I just need to delete this. And let me check now. Yep, there it works. Add text. Oh, I do not have a widget here. Okay, I'll just add them in a moment. Apply filters, we're all working. Blur was working. Let me just revert all the changes. Rotate flip was working, so let me just change the add text now real quick. And yep, text action 1. Exactly. So okay, so I have a default text in case the user did not select this. I'm just going to say hello to the image, and hello will be drawn on the image, written on the image, and then yeah, we just have a text and a font and the button that chooses the choose color method. So yeah, the choose color uses the color chooser, and if I want, so it's just going to ask the color and it opens the color palette. So this is the title of the color palette. Alright, so let's finally implement the save button here. Save action. And this is the exact file. Why did I type it out? Okay, so what we are going to do is, we have the original image, right? So we are just going to get the extension of the image, right? And then file dialog, as we know, has the save as dialog box. So we just get the file name that the user wants, the user type there, and then we are just going to kind of concatenate this string. So file name, the user type, and adding a dot and the original file type extension. So and then the image that edited image is the final image that the user has actually clicked on the apply button and made his choice. So we're just going to get the image, or else I'm just going to use this directly here. Okay, so and then we're just saving the file name to self.filename. So this completes the project. Cropping, adding text, drawing out the image, applying filters, and saving the image. Yeah, right now my GIF extension is not being recognized by Tkinter, so yeah, JPG and other types of images should work fine.